Welcome back. Today we're going to be looking at finding the derivative using a shortcut. Notice that it's not using first principles anymore. We're using a shortcut. Now this is going to make your life so much easier. Let's begin. We're told that if we have some function that's a power of x, right, x to the power of some number, n, then when we differentiate it to get f dash of x, all we need to do is drag down the power. So the power, whatever it is, we move it to the front, and then we minus 1 off the power. And of course, I have to give you that memory tip, right? How we memorize this rule, or this shortcut, is we say drag down the power, minus 1 off the power. Right? So just prepare for the fact that I'm going to say that like a billion times throughout this video. So let's actually, of course, apply this rule, because there's no way that we can actually understand how this works without applying it. So let's have a look at part A. So when we do f of x is equal to 8 minus 3x, we are going to think about what power of x we have. Now, if you look at that 8, you're like, well, there is no x in that. Well, actually, there is. It's just hidden. It's actually 8 times x to the power of 0. Now, what happens when we drag down the 0? Well, what we get is 0 times 8. And 0 times 8 is 0. And so f dash of x, when I differentiate 8, when I differentiate any constant, I get 0. Now what happens when I differentiate 3x? Well, 3x is actually 3x to the power of 1. That 1 comes down to the front, so I get 1 times minus 3, right? So really I should have written it like this. So really 1 times minus 3 is just 3, minus 3. And then the x to the power of 1, well, I've got to subtract 1 off the power. So 1 minus 1 becomes 0. And x to the power of 0 is just, well, that's just 1. And so the answer is minus 3. All right, let's keep going. Let's keep going. What happens when we differentiate 3x squared plus 3? Well, f dash of x, we're going to drag down the power. So 2 comes down the front, so 2 times 3. And then minus 1 off the power. So 2 minus 1, that's just 1. And we said that when we differentiate a constant, poof, it just disappears, right? So it just becomes 0, so plus 0. And so we simplify this just gives us 6x. Okay. Let's keep going. So we've got f of x is equal to negative 2x squared minus 6x plus 7. Let's do it term by term. So f dash of x, let's start with the first term there. Negative 2x squared. We're going to drag down the power. So we get minus 4, because 2 times minus 2 is minus 4. And we minus 1 off the power, so it's x to the power of 1. Minus, now that's x to the power of 1. So 1 jumps down to the front, so the constant doesn't change. And then 1 minus 1, x to the power of 1 minus 1, that gives us 0, right? So we get minus 6 times x to the power of 0. And we already know that when we differentiate a constant, we get 0, so nothing, so plus 0. So what we're left with is minus 4x minus 6. And let's do the last one together. F of x is equal to x cubed minus 5x squared plus 2x minus 1. What do we do here? Well, we do exactly the same as we've been doing so far. We simply drag down the power, so that 3 comes down to the front. We minus 1 off the power, so it becomes squared instead of cubed. And then we just keep going, right? So we drag down the 2 for minus 5x squared, so that becomes minus 10. We minus 1 off the power, so that becomes x. And then for 2x, well, that just becomes plus 2. And then the minus 1, well, that just disappears, right? So I'm not even going to bother writing the plus 0 in this time. It just disappears. And so I'm done. Right? And so do you see how we actually get the same answer here? We don't even need to use first principles. This is the shortcut, right? Like, would you rather do this or would you rather do first principles? Like, obviously this, right? And so this is the shortcut to differentiating any powers of x. Now, it's very important that you answer the question. So if the question asks explicitly for first principles, unfortunately you can't use this shortcut method. If you do use this shortcut method when the question asks for first principles, you will get a fat 0. Okay? So that's very important. Now, 2 observations that we can make. Now, this notation looks very confusing, but what this is essentially saying is that if I were to differentiate, that's what d over dx means. If I'm trying to differentiate 2 functions, like let's say this could be like x squared plus 2x, right? Then I just differentiate the first thing and I add it to the differentiation of the second thing. So I differentiate terms one by one. All right, that's essentially what the first statement is saying there. Okay. The second statement is that the coefficients, so the numbers that are outside the function, they stay there, right? They don't just disappear. What this means is that if I'm trying to differentiate like 6x squared, that 6 stays on the outside. I differentiate 2x, I get x squared, I get 2x, and so that gives me x squared. Oh, sorry, that gives me 12x, right? So the power comes down to the front, so that's where the 2 comes from, right? And the 6 stays on the outside. It just stays there. It doesn't like disappear, and of course 6 times 2 is 12, so we get 12x, okay? Now, of course, I understand that this is a very brief explanation, and I understand that you won't be very confident with this until you get more practice. So I would like you to attempt maybe these, because these are sort of just relying on previous index law knowledge, but essentially all you're trying to do is apply this rule here. So I would like you to attempt it, but don't worry if you get confused. I will come back and help you. Thanks.